Okay, so in chapter 3, we're going to be looking at something called truth tables. And I'll go ahead and give you a heads up. Truth tables are likely something you have not seen before. They're not something that come up a great deal in math classes, but they are important in that they teach us how to think logically. So we're going to be looking at statements. All right. Now, a statement, you've got several examples here, but a statement is essentially just a sentence that can be true or false, but nothing in between. All right. So it can't be subjective in any way. It can't be a question. It's got to be something that has a definite true or false to it. All right, so again, when we talk about what we mean, when we're talking about a statement, it's got to be either true or false. All right, and when we talk about whether it's true or false, what we're doing is assigning it a truth value. So I've given you 3 examples here of statements. And again, the main thing to remember about what makes something a statement, it should not be anything subjective. It should not be a question. It has to be something that can be determined as true or false. So examples, today is Tuesday. Okay, that is either true or it is false, depending on what day it is. Math 103 is a prerequisite for Math 120. That's a true statement. All right, my dog is brown. For me, that's a true statement. All right, somebody else stating it might be false, but again, it's one or the other. There's no in between. All right, so those are examples of what we call simple statements, right? Meaning they just convey one idea. We can also talk about compound statements. So just to give you an example here, a compound statement would be something like, today is Tuesday. And it is sunny. All right, that's what we call a compound statement because it combines 2, or it could combine more than 2 ideas. All right, it could be today is sunny and it is Tuesday and it is hot outside. All right, again, anything with more than 2 ideas is called a compound statement. Now, again, things that are not statements, anything that asks a question, like what day is today, anything that is telling you something to do, right? A command like read pages 1 through 10, or anything that is an opinion, all right? A more subjective thing like Math 103 is the best math class, all right? Those are not considered statements because they do not have a definite true or false assigned to them. Okay, so the first thing you're going to be doing in 3.1 is, again, just kind of understanding what makes something a statement, and recognizing that those have to be true or false. All right, the second thing you're going to be looking at in section 3.1 is what we call a negation. Okay, so a statement, right, is something that is either true or false. The negation of a statement is just something that has the opposite truth value, all right? And it's basically like putting a not in front of it. So if the statement is, it is sunny outside, the negation of that would be it is not sunny outside, all right? If the statement is, it is not Tuesday, then the negation of that would be that it is Tuesday. Okay, they're really just opposite statements, which makes them have the opposite truth value. Okay, so again, I've given you a couple of examples here. If you're asked to write a negation, all right, you're just flipping the statement around to look at the opposite. So if the statement says Paris is the capital of Spain, the negation of that would be Paris is not the capital of Spain. And notice they always have opposite truth values, right? So in this case, the statement is false, right? Paris is not the capital of Spain. So that makes the negation true. Okay, and the same is true if the not's in the statement, right? Again, we're just flipping things around. So if the statement says July is not a month, then the negation, right, the opposite of that statement would be that July is a month. And again, notice that they have opposite truth values. In this case, July is not a month, right? That's a false statement. So when you write the negation, July is a month, that creates a true statement. All right, and anytime we talk about a negation, the notation that we use, so if we want to talk about like statement P, the negation of P is written with this little squiggly line in front of it. We call it a tilde. And that always represents the negation of whatever you have as your statement P. Okay, so again, all this is kind of setting us up for how things are going to look when we start creating these truth tables. All right, now, when we talk about statements, right, sometimes statements contain words that are quantifiers. All right, so kind of group things together. So examples of quantifiers, all, none, a lot of times it's stated as no, and some. We want to make sure that we correctly identify the negation on those, because for most people it seems like all and none are opposites of each other, but that's actually not correct when you go to look at the negation and you make sure that the truth value changes. Okay, so for example, if we have a statement that says all lakes contain fresh water, right? Very tempting for people to want to do the negation as no lakes contain fresh water, right? Well, notice if I do that, then there's like this in between, right? There's this kind of gray area in between. So, when you go from all to none, you're forgetting like one lake or two lakes, right? That's why the correct negation for all is not none, it's that some are not. All right, and you've got a nice little chart down here to kind of help you see how these things line up. Anytime you're dealing with a statement that says all are, the negation of that is not none, it's that some are not. Okay, so the negation here would be some lakes do not contain fresh water. All right, and so for the other extreme on the quantifier, if we have a statement that says none or no are, the negation of that is not all, because again, there's this, leeway in between one or two, so the negation would be that some are. So if the statement, our example here says no birds can swim, the negation of that is not all birds can swim, because there's in between. All right, might be one or two different types of birds. So the negation of no birds can swim is that some birds can swim. All right, if we've got a statement that contains some are, like some students have a driver's license, the negation of some, look at our chart down here, is none. And a lot of times this is written as no instead of none. So the negation of that would be that no students have a driver's license. And then finally, if we have a statement that says some are not, right? In this case, some students do not ride motorcycles. The negation of that would be that all students ride motorcycles. Okay, so again, if you'll kind of remember what you're seeing in this little picture down here at the bottom, right? Anytime you're dealing with all, the negation is some are not. Anytime you're dealing with none, the negation is some. Okay, so let's look at a couple of examples here. All right, and again, let's kind of see that it does indeed change the truth value when we write the negation. So in this case, I've got a statement that says some books are novels. Okay, so I'm going to come back up here just to make sure I pick the right thing. Some are, right? The negation would be that none or no books are. So if the statement says some books are novels, the negation would be that no books are novels. Right? And notice again, they have opposite truth values. Right? Some books are novels, that's a true statement. No books are novels, that's a false statement. All right, my second example here, all coins have the image of George Washington. Okay, so this is like an all are. So the negation of that would be that some are not. All right, in this case, some do not have. So my negation here would be that some coins do not have the image of George Washington. Okay, and again, notice that opposite truth value. All coins have the image of George Washington. That's a false statement. Some coins do not have the image of George Washington. That's a true statement. Changes the truth value. If you go to write the negation of a statement and it does not change the truth value, like if they're both true or if they're both false, then you know you have not done the negation correctly. All right, and then one more example here. This is a case where we have no or none. All right, no well-behaved dogs shred couches. So the opposite of that, all right, here's our no or none, would be that some are, or in this case, some do. So the statement, no well-behaved dogs shred couches, right? The negation of that would be that some well-behaved dogs do shred couches. Okay, and again, opposite truth values. No well-behaved dogs shred couches. That's a true statement. Right? If it's well-behaved, it definitely shouldn't shred a couch. Some well-behaved dogs do shred couches. That has the opposite truth value because it would in turn be false. All right, and then from here, we're going to start learning how to write statements and read statements when they're written in a symbolic form. Okay, so you've got a little summary table here where we're looking at different words that we're going to see in our statements. We call them logical connectives. You've got the term for each one, the type of statement. And then we're going to fill in the correct symbol for each one. So not, we've talked about already. Okay, not is just a negation. And we said the symbol for a negation is that tilde. Okay, so anytime you see that, that is the negation of that statement. All right. If we have compound statements, then they're going to be joined with one of these four that you're seeing right here. Okay, so if you have two ideas and they're joined with and, the symbol is an upside down V, and it's called a conjunction. And I'm going to go ahead and give you a little tidbit here. But is another example of a conjunction because it's pulling two statements together. All right. Now, or on the other hand, we call that a disjunction, and its symbol is a V. If then, that would be like, if it's sunny today, then I will go swimming. All right, that's what we call a conditional statement. And it's denoted with an arrow, a one-directional arrow. And then if and only if, it's like a conditional that works both ways, is called a biconditional, and it's written as a double-sided arrow. Okay, so let's run through these next three examples together, and then I'm going to have you guys pause for a few minutes and do a few practice problems, all right, with the first topics that we've gone through. So in each of these examples, we want to indicate first whether we have a simple or a compound. That's just, is it one idea or is it more than one idea? And then if it is a compound statement, or actually really for any statement we can do this. So we want to determine if it is a negation, conjunction, disjunction, conditional, or biconditional. Okay, so first one, you're looking for keywords. If you write a history report, then the life of Benjamin Banneker would be a good topic. Right? So note your keywords. If, and there's one idea, you write a history report. Then there's a second idea, the life of Benjamin Banneker would be a good topic. So because we have two ideas here, This is a compound statement. And if then is what we call a conditional. And if I were asked to use the correct symbol, right, it would be the one directional arrow. All right, my second statement here, Louis Armstrong did not play the drums. Notice I focus in on these key words as soon as I see them. This is one idea. Louis Armstrong did not play the drums, right? It's just one idea that we're talking about here. So this is a simple statement, but because it has the not in there, that makes it a negation. And then lastly, Inhabor will be admitted to law school if and only if he earns his bachelor's degree. All right, that is a compound statement. It's two ideas, right? So here's one, he will be admitted to law school. Here's two, he earns his bachelor's degree. That's two statements. So it's compound, and the if and only if is what we call a biconditional, and it is denoted with the two directional arrow. Oh, and I forgot my negation. All right, symbol for the negation, if I'm asked for it there, would of course be the tilde. Okay, so I want you to stop here for a minute, and I want you to go through and do some practice problems in 3.1. And the ones I want you to focus on for right now are the ones I have listed for you here. Number 5, number 7, number 8, 10, and 13. Do these in practice so that it's not affecting your grade, and also so that if you have trouble, you can go to your help tools and get some tips in there to help you if you find that you reach one that's giving you a little bit of trouble. All right, so do that, do those practice problems, and then I want you to come back and watch my second video to finish out your 3.1 notes.